Hello, everyone. It's the Deephaven community team here, December week one. We're going to demo some Deephaven users in Streamlit and some IoT devices. So let's get started. All right, first up, we got Alex, and he's going to show us Deephaven and Streamlit. Take it away.
Yeah, so I've put together this little dashboard primarily as a case study of studying the difference between Streamlit, Shiny, and eventually Deephaven UI, trying to figure out what's good in each, what I like in each, what is lacking in each, and sort of how we can think about where we fit into these different platforms. So this is Streamlit. This is using a Deephaven integration that Bender, I think you built. And here, basically, I've pulled some data off of Kaggle on bike sharing in Austin. Bike sharing in Austin is a pretty common thing. So this is a data set that covers 4.5 years worth of data between the end of 2013 and the middle of 2017 over all of the trips that were taken, for how long, and sort of maps out the stations, the to and from these different things. And really the point here, again, is to sort of study the Streamlit integration itself rather than show off something really cool. This was just kind of the vehicle that I used to do that. So these tables are great, right? The scrolling and everything works as fast as you want it to. This data set right here is pretty big. I think like 600,000 rows, something like that. Yeah, 612,000. So all the cool Deephaven stuff works, right? Streamlit's great. It let me do this thing where I can basically execute queries, relatively simple one-line queries here in this text input box. Here's a downside of Streamlit that we'll continue to see. That just took a long time. Of course, it does not actually take that long for Deephaven to run the query. But one thing that Streamlit does that is quite annoying is it recomputes everything top to bottom every time you change anything on the app. So even if you're doing something that's totally unrelated to some other plot, like for example, I have all these kind of interesting questions that I formulated that can be answered in the data set here. If I change something over here, to show me something different on this plot, this one's not the only one that's going to get recomputed. They are all going to get recomputed. You saw that load up there. But the interface is nice, right? They do a good job of making things pretty. It's easy to, select date ranges. I don't like that comes up immediately when I'm trying to select a date range, but they do a pretty good job. The typical Deephaven stuff in this plot works. All that works nicely. There's a lot of sort of interesting stuff that you can look through. I like some of the different statistics in different months on hourly ride duration. Thought that was interesting. And again, none of this stuff actually takes as long in Deephaven as it seems, because everything's getting run top to bottom. Streamlit has these sort of fold out tabs that can provide really interesting ways of collapsing a lot of different disparate information. So here I've got a pie chart. The labels down there got cut off, and I couldn't quite figure out how to get our plotting library to show me all of those. But there's cool stuff in here, and Streamlit as a platform made it super easy to organize all of this stuff. Super easy to sort of lay it out the way that I wanted to, and the actual visuals of it I think are really good. This one's interesting. The distribution of ride durations for people who are annual subscribers and not annual subscribers is very different. The non-annual subscribers tend to take longer rides. They certainly take a majority of the rides. What was it? Over 500 minutes. So just something interesting I found there. Shiny also has, I don't know why that doesn't load up properly initially. They have sort of a simple mapping integration. So I use that to show where all these stations are. You can sort of resize the points by how popular those stations were. And with each of these things that I'm clicking on, I'm running new Deephaven queries under the hood that are showing me this stuff based on the input that's being selected here, right? So it's cool that it all works. You know, I am a big fan of it. I just wish they had a way to not run top to bottom every time. That is one of the few domains in which Shiny is like totally destroying Streamlit, is that they provide a lot of control over the reactivity in their dashboards, and allow you to decide exactly what gets recomputed when. So that's that. That's my demo. You know, it's pretty cool stuff. This is all on GitHub. I can share a link if need be. But there you go.
All right, super cool. Yeah, it's very interesting, and it'll be interesting to see that compared to Deephaven UI once we have the beta out there.
Yeah, I'm excited.
Yeah. All right. So next up we have Devin, and he's going to be demoing some Deephaven with IoT devices, I believe. So Devin, take it away.
All right, let me go ahead and share my screen here. So specifically, I'm going to be showing you a Deephaven workload on the new Odroid M1S with 4 gigabytes of RAM, produced by Hardkernel. This is a company that produces a variety of small single board computers. Most of them are ARM 64-bit computers, a couple of x86, and most of them have a really decent price tag. This one was $50, and it includes a case and a power supply. And I picked it up a couple weeks ago and tried to get Deephaven running on it. A couple more stock photos here. And again, this is an ARM 64 chip. So since we produce ARM 64 images for our M1 developers or Apple developers, it actually works right out of the box on one of these systems too. Here's a kernel screenshot of the system running 2004. Here's the stats of it. Nothing too exciting. Again, 4 gigabytes of RAM. So here is the instance, Odroid, port 10,000, and I'm going to be running a real workload here, not some toy workload. So I've got a Kafka stream from some services that I run. I'm going to be ingesting a lot of data, filtering out just the temperature sensor that I have outside, and then making sure I only keep up to 100,000 of them in memory. So I'm going to go ahead and run this. Hopefully it works. And there we go. We've got some Kafka stuff coming in. I will reverse this so we can see starting to flow in. We can go ahead and plot this in real time too. So we can see this is ticking away. Looks like this data set started on August 29th, and it will catch up. It seems to maybe go over a day's worth of data in 1 second. So it might not be the fastest machine, but it is chugging along surely. We could also go up here. I enabled the GC stats. So we could go ahead and look at the GCs that are happening here if we wanted to get some idea of what the memory pressure on the system is. We could also go look at this chart right here. Looks like we're only using about a half a gigabyte of memory. I forgot to mention, I'm only giving this process 1 gigabyte of memory total, and it is seeming to handle this just fine. And then, of course, we could subscribe to that data from somewhere else. So I'm going to jump from this remote machine, remote $50 machine to my much more expensive desktop here. And I'm going to go ahead and load it up through a URI. So I could go ahead and just do a barrage subscription right here, get the data over to my desktop. We'll just reverse it so you can see it actually is ticking here. And there we go. We've got an Edge IoT device running ARM 64, and it is publishing data from the Edge to my machine here. So there's a lot of potential use cases for these types of use cases and workflows. And I'm generally excited about running things on very cheap single board computers or embedded devices. So if anybody has any interest in trying to do something like this, reach out to us on Community Slack.
All right, very cool. And as I've said before, a gig of RAM should be enough for anybody. So yeah. All right, JJ, are you ready? JJ here.
JJ told me to tell you guys that his computer's totally bricked out.
Okay, so we won't see JJ's demo today. All right, that's all we've got for today, and we'll see you next week. Bye.